Okay, so today we are going to start looking at the SSIS and how we can design the ETL workflows in it. And meanwhile, if you have any questions from the last session, you can just type them in and I'll answer them once we come to a logical point in our presentation. So we are going to start with SSIS. There are two other parts to it, SSIS and SSRS, which we'll see towards the end of our course. So first, let's start with SSIS and understand the extraction, transformation, and loading of data into database tables or different kinds of destinations. So to log into the, have you been able to install the SSDT on your system?
Yes.
Okay, that's great. Okay, so if you have it, you would already know that you just need to go over here, and I'm using SQL Server 2017. So I go to the Visual Studio 2017 SSDT and I click on it, and this window would open, which would allow me to create new projects. So once I'm in this window, I can just go to File, and I can say New, and I can say Project. And it would give me various options of the kind of projects that I would want to create. So I have the options to create SSIS projects, supporting services projects, as well as the integration services project, which is the one that we're going to create today. Now, when you click on the integration services project over here, you can change your location. You can change the name of the project. So, for example, if you want to put it SSDT session 1 demo, or the important thing is here is to give a meaningful name to the project, so that later on when we execute the project, we understand the functionality of the project and what it is going to do. So give a meaningful name over here and just say okay, and then it would create the project and open up in a new window, the SSIS designer window. Now this is how the SSIS designer window would look, and we can see that there are various windows within this designer. On the left is the SSIS toolbox, which is still loading, so it will show you the different tasks which are available, and it has loaded, and we can see that we have a package.dtsx here, which we are going to design. So we are going to design a package, which is our ETL workflow, and then there are various icons over here, and we are in the control flow. And related to the control flow, whatever are the tasks which are related to the control flow, we can see the SSIS toolbox over here on the left hand side. So we can drag and drop any of these tasks and use it to design a control flow. So this is basically where a package would be designed. Then on the right side, we can see that there's a solution explorer, and you can see that there is a solution. It's now called SSDT session 1 demo, which is the name that we gave while creating the project. So the solution has taken the same name. Then within the solution, we have this project, which again has the same name. And then within the project, we have the SSIS package, which is the actual ETL workflow that we're going to design. And the name of that package is package.dtsx. So if you go to SSIS package, right click, you'll see that you can create a new SSIS package. So you can have multiple SSIS packages within a project and multiple projects within a solution. So this is your hierarchy in the way the projects and the packages are managed within SSIS. There is a solution that you have. Within the solution, you can have projects, which can be multiple projects. And within the project, you can have multiple SSIS packages. Now this package.dtsx, again, you can right click and you can decide to rename it to a meaningful name. So we'll rename it to the same thing, SSIS demo, let's say 1. So again, give it a meaningful name, and whatever name you have given here, it would reflect over here because that is your package name. Now there's some other windows we can see. This is your help kind of window where you have some already created solutions which SSIS itself provides to help you learn the tool. So we can take help from these as well. And then we have the connection manager over here, which we'll see that how we can use it to create connections to different and external sources and destinations. And then this is your output. So you'll see your build output and your execution output in this window. This we'll see if we just select any task, you'll see the description of what that task does down here below. So if we are confused about any task or we need help or advice about any task, we can just quickly look over here and get an idea of what that task would do. Now within this package, if we come over here in this window, we can see that there are different parts to it. And today we are going to look at the control flow and the data flow. The other parts are obviously parameters. So you can parameterize your package, and that would help you to put the variables to different values at runtime and reuse the package for different parameter values or across projects, across solutions. So that is why it is important to parameterize. Event handlers are basically exception handlers. So if any error occurs, an exception occurs while the execution of the project happens, then you can define your event handlers, and this is your package explorer. So this is just a view it will give you a tree-like view of the package that you have created. Now, if we toggle between control flow and data flow, I select data flow, then I can see that the options on the left-hand side in the SSIS toolbox have changed, because the data flow has different set of tasks, and these are all built-in tasks which are provided by the SSIS tools. Now, they themselves are very powerful. So they can complete a task is basically a set unit of work. So they can complete one task. For example, this is your aggregate task. So this would basically perform aggregations or calculations on your data that you provide to this particular task. Now to design a package, the very first step is to design the control flow for the package. Now, as we saw in our last session yesterday, that a control flow is basically designed to define the order of execution of the task. And if you want to do any kind of ETL, if you want to read data from any source, perform some transformation and load it to your target, then you have to design a data flow. So any data related task that you need to perform has to be done through a data flow task. A control flow task is just a task to control the execution of your package. So the first step is to define a control flow. To define a control flow, let's say I just want to do an ETL. I just want to, not even an ETL, I just want to read the data from one of my tables and store it into my Excel file. That is my simple requirement. So what I need to do now is select the data flow task and just drag and drop it over here. And now I have my data flow task over here. And again, let's give it a meaningful name so that it is easier for somebody who looks at the code to understand what exactly we are doing. So let's say read data or we are going to read data from dimension table, which is a dim currency table, let's say. So read dim currency data. So that is what we are going to design our data flow for. Now, to help somebody understand more or give a brief summary of what this package does, we can also do an annotation. So just right click anywhere on the package and you can say add annotation, and you can define what this package does overall. So this is a demo package or whatever is meaningful. So any kind of information, any kind of summary, you can put it here. You can just select it and move it wherever you want to move it. So now the actual task that we have here is a data flow task, and we need to read the data from a table, which is a dim currency table, and we need to put that data into an Excel file. So I need to define this data flow task further or provide the specifications for this task. So I'm going to double click on it. When I double click on this task, I automatically move from my control flow to the data flow. So I can do it manually as well. I can just click on over here, and this is my control flow, and I can go to the data flow directly from here. If there are multiple data flow tasks, then there would be a list in the drop down which I can select. So now we have the read dim currency data, and my requirement again is to read from a table which is dim currency in my database. So the database that we are going to use is a SQL Server database. So it should have automatically installed with SSDT installation. If it has not, then you can install it separately as well. So this is your database, and it comes with some databases by default. So you have your system databases, 4 kinds of databases: master, model, MSDB, and TempDB. And we saw that MSDB stores all the metadata related or runtime related information to the SSIS packages as well. So these are default packages which come with the installation of the SSIS Management Studio or the SQL Server database. So you can create your, oh, okay, sure. So you want me to repeat some part? Okay, okay, sure. Okay, so again, what we are trying to achieve here is read the data from a table called dim currency and then put that data into an Excel file. Now to do that, I have to design a data flow task. I cannot simply go and design a data flow task. A package needs to have a control flow task for that. So I need to add a data flow task, which is on the left hand side, I can see here in the control flow. Then I need to provide further specifications for the data flow task. So I need to double click on this, or I can directly go from here, and then I need to add some stages which we will see. But first, let's understand what we're going to do. So we are going to read from a table which is a SQL Server table. So I have a SQL Server database over here, which is a SQL Server 2017 database. And when we install this database, some of the system databases are already installed. And one of those, as we saw yesterday, is the MSDB database that is used to store the SSIS runtime and metadata information as well. But now what we're concerned with, we're going to read a table which is in the AdventureWorks data warehouse database. So this is a database, this is a test database that is provided by SQL Server itself. So you can just install it. And to do that, if you do not already have it, you can just go to this link. I'll just type this link. And you have 2 databases. Okay, so I've shared the link in the chat window. So in this link, you'll see they have guided on how to install the AdventureWorks OLTP and AdventureWorks Data Warehouse download. So there are 2 kinds. AdventureWorks OLTP is basically a transactional system, and then you have a data warehouse with the dimensions and fact tables and all. So to have enough data to practice upon and play around with, it's good to install both of them. So you can just download by clicking on them. Then you'll get a script file, and you need to copy it to a certain location in the C folder, which the script mentions. So you need to copy it, and then you can just run that script in your SQL Server, and these databases would get installed. So once these databases are installed, you'll have access to a lot of tables which these databases already have, and they have a lot of data. So we can really play around in your ETL jobs or the reporting or analysis services which we'll do. So I've installed both of them. I have AdventureWorks, which is the OLTP database. I also have the AdventureWorks data warehouse, which is the data warehouse database. Now we are going to read from a dim currency table, that is a dimension table. So we are going to go to the AdventureWorks data warehouse database. If you click on the tables, you'll see that there are a lot of tables. The table that we are going to read is this dim currency table. So now through my SSIS data flow, I need to be able to access this particular table. So let's go back to the SSIS designer in my workflow. Now, the first step is to read data from this table. So I need a source. The source that I'm going to put over here is okay, it's not even here. It's not in your commons. So you have to go to other sources and add an OLADB source. Now, there are different kinds of sources, as you can see here. There is ADO, net source, there is ODBC source, and so on. So there are different kinds of connections which exist for different kinds of sources or destinations, which could be databases or flat files or web, whatever kind of destination or source we have. Now, since we are going to connect to the SQL Server database, the SQL Server connects to the OLA DB source, the OLA DB connection. So we are going to use that as a source. So again, just drag and drop it over here. And again, just give a meaningful name to it, to the source. So we can just click over here and say, or we can just when you design the actual packages, you will have some standards. So if you're working in a project, you'll have some naming standards as well, which you have to follow for each of the tasks. So it might be that if there's any source task, if you're reading data from any source, then you have to follow a standard, which is like prefix source underscore src underscore, and then the name of the source. So when you are working in a real-time project, you'll have some standards to follow. So it's the best practice to follow them. So for now, we'll just put any sources, src underscore, whatever is the source name. So now I have a source. And I said that I just need to read the data from this table and put it into my Excel file. So for that, I need a destination as well, which should be an Excel destination. So just go to other destinations. It's again not in the common. So just browse down. Go to other destinations. If it is not already expanded, just click on that and you'll see a list of other destinations and choose the Excel destination from over here. So now I have the Excel destination. Okay. So now I have the DIM currency source and Excel destination. I can again name it like DST, or I can name it as target underscore currencies. So that's my name. Now, if I click on my source task, I can see that there are two output links coming out from it. One is red. So red is obviously the error output link. So we're not going to use it for now. Error output link basically would collect any error records. So it's not able to read any record, or it's not able to load any record in the Excel destination. Then it would collect it into the error output link. So for now, we're just going to see the use of the output link. So just select on it and drag it to your destination. And now you have a link between your source and your target. Your source, which is a database table, and your target, which is an Excel file. Now we've just defined, and we are just saying that it's a source and a target, and we have taken the task, the particular task from the left-hand side of the toolbox. But this is not all. You can see that there are red cross marks over here. So there are further parameters that need to be defined to configure these tasks. So just double click on it or right click and say edit, and your editor would open. Now this is an OLEDB source editor because that is what we specified while creating the package. Now the first thing that we need to specify here is a connection manager. Now you can specify a connection manager from here. The other options to specify a connection manager as well. So if I choose not to specify it from the task itself, you can see that there's a window over here. I can just do a right click and I can say new OLEDB connection. So that would also make a new connection. Now the other option to do that is also to go here on the Solution Explorer, select the connection managers, right click and say a new connection manager. Now what is the difference between these three options? These two options are exactly the same. If you create a connection manager through your task or over here in the connection managers window, then you are creating a connection manager for your package. So this connection manager that you have created would only be available for your package. But if you are going over here on the right hand side in the Solution Explorer and creating a connection manager, doing a right click over here, you can see that comes under your project parameters. So that is one of the project specifications. So the connection managers that you create here would be available to all the packages that you have within that project. So they would be at a higher level. So if you have reusability for the same connection manager and you want to create it at a project level because you want to use it for some other package, then it's a good practice to create it over here. So for now, let's just click on it and create it through source editor. So now I have an OLEB DB connection manager. If I already had some connection managers, then at the project level, let's say I had some connection manager, I would have been able to see in this drop down, those options in this drop down. But I don't have anything. So what I would do is click on the new button over here. And when we click on new, then a configuration toolbox will open. And now you can see that there's some options over here because I have defined these earlier for some other package that I already created. So it is suggesting the same data connections over here, but we are going to create a new connection. So I'm going to delete all these. And now we are going to create a new connection, assuming that we never had any connection and our requirement is to create a new connection. So just click on new over here. And now this connection manager dialog box opens up. You have your provider as native client 11.0, just leave it as it is. If you have something installed on your local host or something, you can just click on this and it would retrieve the server names. If you have installed probably with the SSDT, then you would have it. But I had it separately. So my server name does not reflect over here. So what I'm going to do is go to my SQL Server database. And let's say I do not know my server name. So it comes in when you try to log into your database. You can just copy it from here. This is basically your server name that's reflecting over here, but I can find it through a query as well. So I can just do a select at, let's say, server name, and it would give me my server name that I need to connect to. So I can just copy this information from here. So just do a select at server name, and I get my server name. So I'll go back over here because it has not been able to fetch it for itself. If it is able to fetch it for itself, then it's well and good. The other thing you can try, if your database is installed on your local host, just put a dot and it should be able to connect and go over here and try to fetch the databases. So if it is able to fetch the databases on your local host, then you are able to identify your server through this connection manager. But if not, then you can just go find out your server name and just copy it over here. And now ask it to load the databases. So whatever databases are created within this instance of your SQL Server database, they would be listed over here. Now we are going to read the DIM currency table from the AdventureWorks data warehouse database. So I'll select that. And you can test a connection over here if you want. So just press on test connection. It would say test connection succeeded. Do an OK. Just do an OK over here. So now you have a database connection created for your AdventureWorks database in your SQL Server instance. So just say OK, and it gets automatically selected over here. Now, what is my data access mode? The data access mode is table or view. You can also define a view name variable or the SQL command or a SQL command from variable. So we'll see in more detail when we learn about variables, how to do that. But for now, because we're going to read the entire table, let's just say table or view. And then come over here and click on the drop down and select the table that you want to read the data from. So we need to read the data from the DIM currency table. Just select that. You can do a preview if you want at this stage. So, okay, let's do a preview. And what it would basically show is the data from this table, and it would limit it to the first 200 rows. Okay. So if you want to get an idea of what kind of data you're fetching, you can do a preview over here. Just close it. Then go to the next tab, which is the columns. So you have all your columns which you want. If you do not want some column, just deselect it. Right. So we are going to take all the columns, and then you have the error output, which is basically if some error occurs while reading the data from this table, then your component will fail, which in turn will fail your package. That is what is defined here. We can override this again, which we'll see later when we do the error handling stuff. So for now, we just want the columns to flow through the output link, and we want all the columns to come through. So we have just selected all the columns. Say OK over here. And now you can see that the red cross mark has disappeared because we have defined all the necessary properties which were required for this stage. Now the next part that we need to do is define those properties for the target stage. So again, double click on it. And now in SSIS, to connect to any kind of data source or destination, you need to define your connection managers. So be it your Excel files or flat files or databases. So there are other ETL tools wherein you need to define your connection managers only for databases. They simply go to the path, the Unix path or the Windows path of the Excel files and flat files, and directly connect to them without defining an explicit connection manager. But in SSIS, you have to define it even for a file. So now we are defining a connection manager for the file. Again, you need to, if you had already defined something, you would have got some values in your drop down, which you do not have. So we are going to click on the new button. So this is simple. The only thing that you need to define is the Excel file path. So you can browse and select your location. So I have already selected, let's say, some location. And then you can give a file name. So this is currencies. So let's say list of currencies. And it would take all these Excel extensions. So just say open over here. And it has automatically taken this 97 to 2003 option. You can change it if you want. And then the other option over here is first row has column name. So if you want the column names to appear as the first row in your Excel file, which you have defined over here, then you can select this. If you do not want that, you can deselect this. So, okay. So now I have my connection manager established. Okay. Now my access mode, again, I have the same options. I can see the table or view, table name or view name variable, or I can even give a SQL command. And the SQL command here is different from the SQL command that we talk about when we take data from a database. It is basically defining a range. So I'll give you an example and you can try it later on. So if we want to just load data into the whole Excel file. Now the next step you need to do is name of the Excel file. If you click on that, you would see that no tables or views could be loaded. This is the message that you'll get. So here we have created an Excel connection manager, and even though we have given a file name, here it does not recognize it in the name of the Excel sheet because that file is not already created. So what we need to do is basically click on new over here and create the file. So it generates its own create statement in terms of it's almost like creating a table. And this is how it is going to create it. And these are the data types it's going to put. It's going to assume those fields the coming from the source to be having. So you can change that if you want. The important thing that you can change here is your file name. So we decided the file name should be list of currencies. So let's put that over here. And say OK. And now it gives you a message that please select that Excel sheet from here because you need to have some selection over here. So go back to the drop down and you'll see that there are different options over here for the same field. So this is basically your workbook with a dollar over here. This is your worksheet within the workbook. The list of currencies, the Excel file. This is the same. It's called a named range. So it is basically the same. It would do the same thing. But if we had selected SQL command, then it would be, this is an unnamed range. So if we had connected SQL command, it would have been a named range, which is from, you would have specified the cell numbers. So let's say A1 to B2. I want to put my data from A1 to B2. So something like that. So for now, we are going to write the whole data to a sheet. So we'll just select this option. It's always better to select the option with the dollar. And then the next step is to go to the mappings. Now by default, it would automatically map if the columns have the same name in the source and the destination. So all the mappings have already been done. If they would not have been done, you could just right click and say map items by matching names. So since they're matching names in the source and target, at this point, it has automatically mapped them correctly. So we do not need to do any remapping. So we are fine with it. We can just say okay over here. And now you can see that that red mark over here has also disappeared. So now we have fully created our package and we are ready to execute this package. So what is the next step to do that is just go and save your package. So this gets saved and then we are going to execute the package. So for now, when we execute the package, we are just going to hit this button, which is basically a debugging button. So we'll just start and keep an eye open for what are the messages that we're getting in the output window. Just select start over here. And you'll see that there's something called build complete, which is basically like a compilation of the code happening, and it says that the build has completed successfully with no errors. That means there were no syntax errors in the code and anything like that. So even if there would have been any syntax errors, we would have known because ideally it should have shown us the red crossbar at that time. And now after that, what happens is basically it moves to the next screen and puts a green tick mark over all the tasks that we included in a package. And it also gives us data flow in terms of the number of rows which have been read or transferred from the source to the destination. Also, now there is another command at the bottom, and it's very important to click that command because it's still in the debug mode. It's still executing it, though the whole data flow has completed. So we have to manually stop that by clicking this button, and then it would go back to the design mode. Now, since everything it said happened fine, and you will have all your messages over here if you want to go deep into it, you can see this. Or if the package would have failed, then these messages would have been helpful as to where it failed. So now for this package, it said that everything has happened successfully. So our next step is to verify what has happened. So we'll go back to the data location that we specified. And sure enough, we have this file, which is an Excel file list of currencies. So we are just going to double click on it and check if it has loaded fine, and it has loaded fine. So you can see that the worksheet name is also list of currencies, and whatever columns were there, the first row is the column name, right? And then you have all these information from the database table into your Excel worksheet. So this is a simple flow. This is basically connecting to the source database and writing the data into a destination, which in our case was an Excel file. So similarly, we'll be doing more derivations now, more transformations. We'll be including some transformations. We'll be loading to the database tables as well. So before we go to the next step, which is reading from one table and then loading that data into another table by creating that table through SSIS itself in another database. That is what we are going to achieve next, and then we are going to use that table for different purposes. So before I move on to that, if you have any questions, just type them in, or we'll move forward with the next package that we're going to create. Okay, so let's move on to the next step. So you can keep on trying all these, and if you are stuck somewhere, you face any difficulties, just let me know. Uh, so for now, we'll move on to the next thing that we want to achieve. Now here we have design. We have read from a database table and put it into a target destination, which was an Excel file. Now I want to create, so I'm just going to remove everything now and create. Okay, so go back to the control flow. And instead of read dim currency data, now I'm going to read, let's say, I'm going to read HR employees data. Okay. So now what I'm going to do over here is, let's go back to a SQL Server database. Now what I'm trying to access is my Adventure Works table. So I'm no longer in the Adventure Works data warehouse. So you can see in the Adventure Works database, if you click on the tables, you can see there is a table called the Human Resources or Employee. If you click on it, click on the columns, you'll see whatever other columns which are available here. So we are going to read from this table in our Adventure Works database, and then I'm going to create this table with a similar structure in another database that I have created, which is called the SSDT database. And then I'm going to load all the data from this table into the SSDT database in the table that I create with a similar name. So that is what I'm going to do now. So let's go back to our SQL Server Integration Services Designer. I have the data flow task already added, so I just double click on it to configure this task. So again, I need a source, I need a destination. Now what kind of source I need? I need a similar source, so that is the OLA DB source, because we are connected to the SQL Server database. So I have this source here, and I want a similar destination now. I want an OLA DB destination, because that is, I'm going to create my table in the SQL Server database. So now I have an OLA DB source, OLA DB destination. I'm just going to connect the output link over here. Now quickly go to the OLA DB source, and I need to define a new connection manager now because I'm not using the Adventure Works database. So I quickly say new, and I give my server name, and the database that I select over here is now Adventure Works. Okay. Okay. Table of view. Okay. Access mode is right. The table that I want to select over here is the HR employee table. So I can see that in the list. I'll just select that. All right. Go to the columns or do a preview, whatever you want. All the columns are listed over here. I'm going to read all the columns. If I do not want to read, I can just remove that. Okay. And then we have the error output, so which we'll see later. Then I go to the OLADB destination. Now I want to create this in a database, in a different database, that is the SSDT database. So again, I need to create a new connection manager. Again, I'll click on new. Again, I go over here to new and put my server name. Select the database in which I want to create my table, which is my SSDT database, and say OK, and use that connection manager over here. Now table of view, I want to do a fast load option, which is like a bulk insert option. I want to load the entire table. Now if I click over here, I see a table which is a dim currency table, and that is certainly not the table I want to load the data to. So that table that I want to load the data to does not still exist in the database. So what I need to do is click on the new button over here, and SSIS would automatically create that table for you. It would give you a create tables index for that table, and by default the destination name that it would choose is the OLADB destination. So we want to change that. We want to put that name to HR underscore employees. So you can change that name over here and just say OK. So now I have that table which would be created by SSIS itself. Now I have some options over here which I can choose to check or uncheck. The first option is keep identity. So keep identity is basically, it's false by default. As you can see, it's not checked in. But if you check this, what it would do is basically keep your identity value. So if there's, let's say, some identity column in a SQL Server table is nothing but like it's a auto-generated primary key column. So if you have that kind of column in your source table, and since you are creating a new table and loading data to it, if you have any identity values coming in from the source table, it would populate the same values in your target table. But since we said identity is an auto-incremented, auto-generated column which is generated by the SQL Server itself, we do not choose this option because we want SQL Server to keep on generating the values automatically, because they would not have any business sense in any case. They're just used as surrogate keys to perform joins between the different tables. So it's better to keep this unchecked. Then this is basically nulls. So if you want to keep nulls in your data, if there's blank data somewhere, if there's empty data somewhere, if you want to keep that, you can select that. Then the other option is table log, which is selected. That is basically while the loading is being performed of the data, because it's a fast load as well, which is a bulk insert, while the loading is being performed, that table would be logged for that duration. So no other operation on that table would be allowed. No other update operation, select operation would be allowed on that table. So this is a good practice, because if you're loading the data at the same time and then there's some other operation trying to update the data in that table, then your data might end up being inconsistent, and there might be other issues with the availability of the connectivity in the SQL Server database itself. So you have to log the table whenever you're writing data specifically to a table. It's a best practice to log that table for that duration if the duration is not too high. Then the other option that is selected is check constraints. So if there are any constraints, uniqueness constraints on that table, any referential integrity checks that need to be performed. So you have to check that constraints while loading the data so that you do not end up with duplicate values or inconsistent data in your target table. Now, the other options that you can define, and this is especially true for big tables, data warehousing tables, which have huge volumes of data, you can select your rows per batch and the maximum insert commit size. So basically, rows per batches, any operation, SQL Server, any database specific operation is performed in batches. So the batches have some records, some amount of records in it. So if you want to specifically define the number of rows that each batch should have, you can define it over here. Now, these are basically performance tuning parameters that need to be set up, especially in case of ETL workflows which are running slow because of the large amount of data. So they have to be set up with a lot of testing. So you have to test that what should be the optimum value that should be there. For each job, you would have some optimum value that needs to be put over here. If you are not doing any performance tuning, if your ETL workflow is working fine as it is, by the SSIS, it's good to let SSIS automatically decide these things and not put these values. These are advanced performance tuning measures which are done specially to debug slowly running jobs. Then you can define your maximum insert commit size. So this is basically after how many records a commit would be made in the SQL Server. So let's say there are 1,000,000 records in your source table and you're trying to insert those 1,000,000 records into your target table. Then after this much amount of records, a commit would be made. So those many records from the memory would get transferred to your SQL Server table, would get loaded to a SQL Server table, and a commit would be made. So this is needed again because whenever you are loading 1,000,000 records, if you do not perform a commit, then what would happen is all those 1,000,000 records would remain in the memory, would slow down the database, and your job might end up running indefinitely. So you need to have a commit size. This is the maximum commit size that is recommended. Now, on the other hand, if there are small tables, you want to quickly finish your job and you're not concerned about the huge volume of data, you can have a value which is 0 over here. So when you have a value which is 0, it is basically that the entire data would be loaded into the table, and only then a commit would be performed. So that would be a very fast loading option that can be chosen as per your requirements, but only in cases of loading data which is not huge in size. So all these things again depend also on your database capacity, because the database that you're working on would have different capacities. So how highly efficient that database is, what are the performance characteristics of that database, what is the power of that database, all those things would decide all these things. So before changing any of these values specifically, just design your job and run it. Try to design it wisely if it is running slowly, and if it does not work, then come back to these things and try to change them. Again, do them with consultation with the DBA, because he would be better able to guide you in these particular aspects. So now we have defined all these options. We have left all those options to their default values. The next step that we're going to work on is the mappings. And you can see when you are in the connection manager, it was giving you a message over here that define the mappings. Go to the mappings and define them. So you have to click that. And again, it has been able to map them properly. We can see. And that is because it matches on your matching names, and all the names are similar in the destination column and your input column. If you would have changed any column names, then you might have to put the mapping manually. But since the names are same in the source and the destination, all your mappings have been done correctly, so we can just say okay. And now we can see that we have the source and destination defined. There are no cross marks. That means the syntax should be correct. So we'll check it by saving this project, this package, and again running it. And the build is complete, 0 errors, 0 warnings. So what you should be getting is green tick marks over here. Green tick marks means everything has gone fine. So we are safe for this time. And it also shows us the number of records which have been transferred from your source table to your destination table. You can just click on this to stop and come out of this mode. And then we can go back to our database and let's see if this table has been created. So where we were trying to create it was the SSDT database. So just go over here, click over here, see if a table has been created, and sure enough, a table has been created by the name of HR_employees. And it has your columns. So you can just run your statement over here. So you can just put your statement and see what is the data in this table. So select star from HR_employees. And you have to run it in your SSDT database. Change it over here. And you can see that some data has been inserted over here. So this is binary data. You can see over here that this is defined as a binary column. That is why it looks like that. Okay, so this is how we can read a table from your database. You can use an OLEDB destination source to create a table with similar structure, or you could have changed the structure as well. So you could have not selected all the columns. If you wanted to change the structure in terms of reducing the number of columns, you could have just selected the columns you wanted. You could have removed the organization node, and then you would have created a table with only these number of columns. So you can change the number of columns as well, and then create that table, load that data from the source table into your target table. So this is how you can load that data. Now these are the ETL workflows that we have seen so far are very simple. As you would agree, they are simply reading from the source database, or so we have till now only read from the source databases, not from any flat files or Excel files, and we are outputting data either to a database table or to read it to an Excel file. But it's not so simple every time. When you work in a real-time project, these might be your derivations that you would need in your staging area, just copying the data from the source to the target. But when you design an ETL workflow, the important part over there is your transformation. So we need to perform some transformation on the data and then load it to our output target, which could be a database table or a fact file or an Excel file or whatever it is. So we need to perform some transformation. So where do we perform that transformation? Those transformations are again performed in the data flow task. Anything related to the data, reading the data, writing the data, transforming the data, has to be done through the data flow task. Now coming back to the toolbox, let's see what all options we have available. So we had a lot of destinations, so we do understand what is a destination. We had a lot of sources which we could connect to. Then I have got something. So there are a lot of source destinations and transforms available in the common tab. And then there are some other transforms as well, as you can see here. So let's go to the common tab and try to use some kind of transform. Okay. So let's start with the very first transform that we see here, which is an aggregate transform. Now, aggregate, as the name suggests, obviously would perform some kind of aggregation on your data, and that would be the transformation that would be performed, and then you would be loading that data into your target. So if I remove this target, let's remove this. So I just have my source over here. I can just drag and drop my aggregate, and then I can select my output link, select it to the aggregate over here. Let's go back to the source and see if it's already defined, because there was no, okay, let's cancel because we unnecessarily changed it. There's no red cross mark, that means the characteristics are already defined, so we do not need to redefine it. So let's go to the aggregate and see what we can do. Okay. So now we have all these columns from the source stage that we defined. And now I need to perform some aggregation. So what I'm going to do is, basically, I have this table. Okay, so this is a similar table in the AdventureVerse database. So what I'm going to do is, there's something called a job title. So I'm going to count the number of employees by each job title. So how many employees are there for each of these job titles? So that is what I'm going to do. That is the kind of aggregation I'm going to perform over here. So let's go back to the SSIS designer. And since I'm going to count the number of employees by the job title, let me find out where is that column called the job title. So here is that column. Let's just click on it and say job title. So I want this in my output. My output name would be the job title, which is all right. The operation, it has automatically taken group by, so I'm okay with that. Now what I'm going to count is the number of employees by this job title. So to count the number of employees, the column that I'm going to choose is the national ID number. So that would be the employee ID. That is something like the employee ID that would be unique to each employee. So I can safely count it. So I'm going to add that column as well. So it adds it as a national ID number. Now, these are the only two columns I want for now. So I'm going to now look at the properties which have been defined over here. Okay, so I want to count by the job title. So grouping by the job title is correct. So I would just leave it as it is. I want the same name in the output so that I can understand what it is. Comparison flags, count distance, scale count, distinct keys, all these. We are not counting a distinct, so we are not going to define those. Comparison flags are basically, do you want to ignore character width? Do you want to ignore case? So if the department name, the same department name is in lowercase and uppercase, do you want to count them as two different job titles or the same job title? So all these things you can define over here. Kana type is nothing. It's a Japanese thing. So just leave it. Then you have these other options: count, distinct, scale. So basically, if it was a decimal value or something with a scale to it, you can count it to what scale it would be the same. It would be counted as the same. And if it is like the last three characters would be rounded off and counted at the same, or you would count all the to your precision and scale as separate items. Then count distinct keys, you can say yes or no to count 1 or 0 to count distinct keys, which is basically you want to count only the, so it would be more specific in this case because here we have grouped by. So if you want to count the distinct occurrences of the employees, or you want to count all the occurrences of the employee. So if there were two records for the same employee ID, do you want to count them as 1 or you want to count them as 2? That is what you can define over there. So I need to group by the job title, which is okay. So leave it as it is. But I do not need to group by the national ID number. What I need to do here is count the national ID number. So you have your options over here, count and count distinct. So what I can do is count. Now let's say, let's try to add some other column. Say, let's say hire date. And okay, so what I'm basically trying to show here is that depending on the kind of column that you have added and the data type and whether it's an identity column or not, it would suggest the group of the kind of operations that can be performed on that column. Now, when we had the national ID number, you can see that it's only giving you the options of either grouping by it or counting it distinct, the distinct values of it. But if you use a hire date, you have some other options available as well. So you can do a count if you want, and you can also find out the minimum hire date or the maximum hire date. So depending on the kind of column, the data type of the column that you add over here, the operations would be listed. Okay, so we do not want that column for now. For now, we are just counting the number of employees against each job title. So we are safe here. I can just say an OK. And now this is also totally defined. Now I want to collect these records somewhere. So I would just define a source again, sorry, a destination again. And destination that I'm going to define this time, let's make it simple as a flat file destination. So just drag and drop over here, and here you can just connect output to the flat file destination. Now again, there's a cross mark, so we need to define some characteristics over here. So double click on this, and again you need to define a connection manager, which we do not already have. So go to the new button. And just first step, define the number of the kind of flat file you want to create. So flat files are different kinds. Basically, they can be delimited files. Delimited files are nothing but the files which have a delimiter as column. That's a column that separates the column values. So it could be a comma, it could be a pipe, it could be anything, a tab or anything. Then they're fixed with flat files where you define a fixed length for each of the column, and it specifies those many bytes all the time. So that is a fixed width file. Fixed width with row delimiters. If your rows are separated by a distinct delimiter, you can define that. Then there's another kind called ragged right. So this is a strange thing. It has columns which are defined by fixed width, except the last one, which is delimited by a new line character. So whatever is your option, most of the times it would be a delimited option. So just say OK, and then click on new again and define your connection manager. So you can define a description, you can give it a meaningful name over here, which is always a good practice. Do that. We have not done that for this example, but give a meaningful name over here so that anybody who wants to reuse this later on, or anybody who's looking at the code, can understand what the code is doing. So the next thing we need to do to define a flat file connection manager is to select the file name. So same as for the Excel file, you need to select your destination and give it some name. So what we are doing over here is we are selecting the list of employees. We are doing a count of employees. So we can just say employee count. And automatically it would take the extension of .text. Okay, you can Define it to be Unicode if you have some other characters coming in, like the French characters, the Spanish characters, the dark songs, and all those things. So you can define it as Unicode. We define your locale. So because this is English, we can just leave it as it is. If it would have been some other language, Japanese or something, you could change that and define your code page. So code page is basically defined for the different languages because they have their own specific characters which need to be read correctly. So for that, you need to define all those properties. The format we define as delimited, so that is okay. The text qualifier, we can define text qualifier is basically none in this case. This basically means whether your input columns are coming. So this is a destination. So whether your destination columns should be enclosed within, let's say, quotes or double quotes or single quotes or something like that. If you want to do that, then you can define a text qualifier. Header row delimiter by default would be this is a carriage return. You can define your header rows to skip. So if you want to read from the 5th line, then you can define it as the 5th line. Since we are writing it over here, you can write from the 5th line and so on. Then the other option is column names in the first data row. So do you want the column names? We can just select it. Also, okay, we want the column name. Then we want to go to the columns. So we have 2 columns, job title and national ID number. The delimiter, it has chosen as comma, which is okay for us. So we'll just leave it as it is. If you want to change it, you can just go to a drop down and select whatever kind of delimiter you want. So different options are provided to you. Then you have some advanced properties. You can define your input column width, your data precision, your data scale, your data type, your output column width. So if you're expecting greater than 50, you can specify it as more than 50 and so on. You can define this as false or true, whatever you want. So for each column, you can define it. Let's put it as false and see what happens. Then you can preview. Data rows to skip 0. All right, so there's nothing to preview. Job title, national ID number. This is how it would look like. Let's say okay. Then now there is a message over here which you can see that says map the columns on the mapping page. So we need to do that. So go to the mappings page and they're automatically mapped correctly. Again, because it's the same column names. So say okay. Now, let's go back to the aggregate stage. We really do not want the same column name, right? Because we have we are doing a count of the employee number. So we do not want the column name to be national ID number. We want it to be called employee count. So I can go to the output alias and change it. Employee count. Okay. So let's do that. Then go back to the flat file destination, go back to the mappings, and okay, it has correctly mapped from the employee count to national ID number. That's great. But sometimes this link would be broken. It would be something like ignore over here. So this link would be broken. So make sure by going to the mappings tab that they have been mapped correctly. So it was already mapped. That's why probably it has taken it correctly. But if you had already changed the name in the aggregate stage and then configured the target destination flat file stage, it would not have been able to map it because they do not have similar names. So make sure that the mappings are always correct. Okay. So now this is what we wanted to design. This is what we have done. So we'll simply save it over here and execute the package. So build complete, 0 errors, 0 warnings, so we should be good. And we have green check marks across all the stages, so the package has executed fine. We can see the data flow as well. There were 290 rows which were read from our source. Then some aggregation happened. There was a count calculation being done, and then 67 rows got loaded to a flat file destination. So let's go to a flat file destination and try to see. So we have this file which has been created, the employee count. Let's just double click on it and you can see the first row is your column names. This is your job title. and it was a comma separated file because we defined comma as a delimiter, and then you have 4. That is the count that you have. So this has come correctly. So this is what we wanted to achieve, and this has been written correctly in our employee count flat file. Okay, so do not forget ever to click on this and go back to design mode. Otherwise, the process will be hung in the background, which we do not want. So we want to come out and come after checking our data flow, we want to come out and back to a designer stage. So this is back to the designer stage. So now we have used one of the transformations as well. So I'll again stop for 5 minutes over here. Just go through it and try to do it on your own in your own installation of the SSIS. And if you have any doubts, just type them in or speak them out and let me know. So mm, we'll start back at 8:14. So just try to assimilate whatever we have done, we have learned so far, and then we'll proceed with some other options that we have, which we can use in the data transformation. Okay. Okay. So you can keep on typing in your questions in the chat window. Let's move on meanwhile to see some other options that we have available over here. So now every time we have designed a package, we have been going to a destination to verify whether execution has happened fine, whether whatever was our requirement has been achieved or not. But what if I want to view the data intermediately in my SQL Server Designer window itself? There is an option for that. It's a very handy option. So you can just click on the link where you want to view the intermediate data, and you can just say enable data viewer. So just click on that and you'll see a sign over here. So now we will save this package again, and if we run this, what will happen is that while the package is being executed, a window will pop up which would define some data. It should give you a preview of data which is going through that link on which you have defined your data viewer. So you'll be able to see through your SSIS designer itself, instead of every time going back to your destination and checking, and sometimes you may not be having access to that destination and stuff like that. So you can simply see the data here. You can copy the data to Excel if you want to do some further analysis or anything. Now the next thing we need to do is let the execution of the package get completed. So if you have included a data viewer and you have viewed the data, you have to go and click on the close button over here, and then you'll see the green check marks have appeared and the package has completed. And then we have to click on this button. So this is a very good tool that we have, and it's very helpful for especially debugging, or if you want to just get a preview of the data that you won't be fetching, or if you just want to check at every stage what exactly is happening. If you're debugging at some point, you do not know at which point the data corruption is happening or the error is occurring, then you can include these data viewers and find out what exactly is happening at what stage. So these are very powerful tools for debugging. Now, if you right click on this again and say edit, what you can do is go to the data viewer tab over here, and you can define the number of columns you want to see. Now we had just 2 columns, so it was very easy for us to see. But when you design the actual big jobs, and you might be having a lot of columns, and you do not want to waste your time checking the values of each of the columns, so you can just select the displayed columns, the list of displayed columns. So if you do not want the job title, just click on it and let it go to the other side. Or similarly, you can select your columns you want displayed, click on the right arrow button and get them added to the displayed columns. Okay, so this is a very efficient tool, especially useful for debugging and previewing your data. So this is what you can use. Now, let's see some other data transformations as well. So now we have aggregated the data. Now let's explore some other data transformation, which is, let's go and explore the conditional split transformation. So again, just drag and drop, put it over here. So now you have another stage added to your package. Just click on the remove the flat file destination, or let's undo it. Let's click on this link, delete it, and now we have to redirect the flow from the aggregate stage to the conditional split stage. So I'm just redirecting, and the output from the conditional stage I'm redirecting to the flat file destination. Okay, so this is your data flow now. These are the 4 stages. So what this conditional split task is going to do, it's like a filter. So you can split your data based on some condition. So you can apply a condition, and the condition that we're going to apply over here in our scenario is, now that we've already aggregated the data based on the job title, so we know how many employees are there for each job title. Now our requirement is to see that how many job titles are there which have an employee count of greater than 4. So that is what is a requirement. So I'm only needing to collect the data for those job titles which have an employee count of greater than 4. So I'm going to use this conditional split transformation for that, and it would act as a filter. I can specify my condition of the employee count being greater than 4, and it would only output data that satisfy that condition. So we already have our aggregation defined. So let's go to the conditional split and define some conditions. So you can see that there's a default output name always created, which is a conditional split default output. And if I just cancel it, you can see that there is no cross mark over here, red cross mark over here, because there's already a default output link that is created that outputs all the records for which any condition has not been defined. So no condition has been defined as yet. So it's a complete stage in itself. If we run this package now, then all the data would flow to the output stage. But we want to define a condition. So let's double click on it again and define a condition. So the conditions can be defined here. If you had defined some variables and parameters based on which you want to define some dynamic conditions, we could have used the variables and parameters, or we can simply use the columns and define some condition on these columns. Now, what exactly we wanted to define was all the job titles for which the employee count was greater than 4. So I need to use my employee count column for that. But what is the function I need to perform? So let's just put the employee count, and now it has already taken an output name of case 1, which you can change. So you can say, let's say employee count greater than, so it won't take that. So employee count, you can just put greater than 4, something like that. You can put a meaningful output name. Then we are going to define the condition. So our condition simply is employee count greater than 4. Now, if I click outside, I can see that there is a red, the text is still in red, so there must be some error to it. If you want to see exactly what is the error, you can just go over here, hover over here, and you will be able to see the error. The error says that the data types, and let's do an OK so that we get an error over here. So the error says that the data types DT underscore UI8 and DT underscore I4, the data types DT underscore UI8 and DT underscore I4 are incompatible for binary operator. So it says the operand types could not be implicitly cast into compatible types for the operation. To perform this operation, one or both operands need to be explicitly cast with a cast operator. So it's asking us to cast the data type of the employee count column to the one which can be used with the binary operator, that is the greater than operator. So this DT underscore UI8, it's basically a Unicode kind of data type. It's not able to assign a binary operator of greater than to this data type. So we need to cast it to a compatible operator. Okay, so let's try to do that. Let's say okay. And casting, how can you do the casting? So if you see on this right hand top side, you can see that there's a list of functions that is available to you. All these are transformation functions which you can use for defining your condition. So you can perform transformations on your input columns, or if you had variables or parameters, you can perform different kind of transformations on them and then use them to define your condition. Now, since we have been asked to cast this column, let's go and explore some typecast conditions. So let's go and click over here. Now, these are your options that are available to you. So what I'm going to do is I'm going to try using the DT underscore I8 function that would convert it from Unicode to I integer having 8 bytes, and then probably it would be able to use this function. Now, how do we use this function? You already see when you click on it, you see how you have to use that function. This is what you have to write. So just copy that, go over here, paste your function, and if you come out, you would see that now this has turned black. If this has turned black, that means the function has been accepted correctly. So this is how you apply function. This is the syntax in which you write. You just put your function like this, dt underscore I8 within brackets. Then you give a space. Then you give your column name or the parameter name on which you want to perform that operation. So this part converts it to an 8-byte integer, and then you have it greater than 4. That is your remaining condition that you want to give. Now, default output name is okay, whatever is the default output name, but the output name on which this condition has been defined is employee count greater than 4. Okay, so we have to map this output link and not this output link. Now, what will this output link have? This output link will have all the records which do not satisfy any of the conditions on any of the other output links. The other output link that we have is only this output link, employee count greater than 4. So all the records basically which do not have an employee count greater than 4 would go to your default output link. Now, what we want to map is, if you click on this output link, then your name of this output link is conditional split default output. We do not want to map this. So I'm going to remove this once again. Just delete. And then when you pull your output link from the conditional split to the flat file destination over here, it will ask you to choose the output link which you want to map to your destination. So output link, you have the two output links from your conditional split stage to choose from. So you can choose the one that you want. So I want the employee count greater than 4 and say okay. Now that is the link that has been mapped over here. Let's go back to the flat file destination, make sure that everything is correct, it looks correct, override data in the file. Yes, please do that. So just select this, mappings are looking all right. So we have everything in place over here. So we can just save this again and run this. So build complete, 0 errors, 0 warnings. All green check marks, everything has gone fine. You can see the number of rows, 290 rows, then 67 rows, and then you have 10 rows which had employee count greater than 4 flowing to your flat file destination. Now, since we did not include data viewer stage, we are going to check in this, and this is the information that we have. We can see over here all the counts are greater than 4. So 5, 15, 14, 9, right? So our requirement has been implemented and our requirement has been achieved. So we are good with this flow. And let's click on this to come back to our design mode. So this is how you can use this conditional split transformation. Basically works like a filter. Okay. So it basically splits the data that comes to its input stream based on different conditions. You can have multiple links coming out of your conditional split. So you can define, if you go back over here, you can define another link with some other condition. So you have all that data coming to that link. The output link will always have the data which is not satisfied by any of the conditions on any of the other output links. So all the remaining data basically would flow to your default output link. So if you want to collect that for debugging, or if that is the way you have designed your job and you want the remaining data to come and you want to perform some other transformations on that, you can collect data from this link as well. So you can attach multiple destinations to this your conditional split. So I can go ahead and let's say there's some other destination I want to put. So just for the sake of it, let's say Oracle destination. Then I have option to redirect the other output to this. And by default, it has automatically taken conditional split default output because that was the only other output link remaining for this data flow. So this is how the conditional split transformation can be used. So let's just remove this. Okay. So now let's say the other requirement that we have is now um, we are okay. We have taken the count of the employees by the job title. We have only collected the employees, the job titles for which the employees were more than or greater than 4. Now, what I want to do is I want to sort that data in my output flat file. I want it to appear in a sorted way, sorted by the job title. So what can I do now? Which transformation can I use? So there's another transformation which is called the sort transformation and which is over here. So now I can use this sort transformation. So I'll just bring the stage over here. My flat file destination is over here. So now this link should go here. So I would just remove this connection from here. From the condition split again, point the output over here, select the correct link name, the employee greater than 4. Okay. Goes to the sort option. From the sort, whatever is the output goes to the flat file destination. All right. So now let's see how we can define the sorting and the sort dialog box. So double click on the sort transformation. The transformation editor will open up and you can see all these options which are present. Pass through means you want these in your output. You want them to pass through in your output. Now what we want to do is basically sort by the job title. So select the column over here based on which you want to do the sorting. So I want to sort by the job title. The sort type is basically ascending. I can define it as descending based on my requirement. I can define it as descending, which we'll see when we implement the data warehouse, the slowly changing dimension that we want, how we can use all these characteristics. The sort order would be 1. Comparison flags are similar. You want to ignore the case, you want to ignore the characters, ignore symbols, ignore punctuations and all that. So you can define all those characteristics as well. So now job title ascending, if I would have been having more number of columns, I could have selected the other columns I want to sort by. So sort order is basically, let's say I want also the employee count to be sorted. So it would define you, the first sorting would be on the job title. Within the job title, so the employee count repeats, then the second order of the sort would be your employee count. So it would be something in a SQL statement like order by job title, employee count. Now, if I change this, I make this as 1 and I make this as 2, then my query in the SQL server would appear like order by employee count, comma, job title. That is your sorting order. So we do not want to sort by employee count, so let's just remove it. By default, this would take it as 1. Now, we have achieved our requirement, whatever we wanted. Now there's one other option which we can see over here, which says remove rows with duplicate sort values. So let's say in our data, which is coming as input to the sort transformation, we have 2 records which have the same job title. So what do I need to do in that case? Do I need to sort them? Or do I need to retain those 2 records, or do I need to remove rows with duplicate sort values? So you can check this option and then it would work as a remove duplicate transform as well. So it would basically, if you want to remove the duplicates from your data, you can use a sort stage, you can sort by the column on which you are suspecting duplicates, and then you can check this column, remove rows with duplicate sort values, and would remove all duplicate data from your input stream. So you can use this option and it would work as a remove duplicate transformation. So basically in the output you would get distinct values. So it would be a select distinct from your source data. So that is how it would work. So the sort transformation can also be used to select only distinct data coming from the input source. All right. So for now, we do not want that to happen. So we can just leave that as it is and just say, okay. And now I have this flow. Everything seems to be defined fine. Flat file destination, just re-verify the mappings once they are defined fine. So we are okay. So save it again and just execute this. So we'll see build complete, 0 errors, 0 warnings, check marks, green check marks across all the stages. So it should have happened correctly. 10 rows came here, 10 rows got sorted and written to the flat file destination. Let's stop debugging. Let's go back, and it has been overwritten at 8:35 a.m. Let's go back and check the employee count. And as you can see, it has been ordered based on the job title in an ascending order. So that is what we defined. All right. So this is how you can perform the sorting transformation as well. So these are the various kind of transformations we can perform. There are various other kind of transformations which are a little more complicated, which we would be seeing in our upcoming sessions. But this is all to give you an idea of how the different transformations can be done. Now, since we have seen quite a bit of transformations, let's explore some other concept that's called the synchronous and the asynchronous transformation. So there's something called the synchronous and asynchronous transformations. Let me write it down for you. Synchronous and asynchronous transformations. So what are synchronous and asynchronous transformations? Asynchronous transformations are basically transformations which cannot be executed row by row or record by record, which means that they need to read the entire set of input records or input data, store it in the memory, and then perform their operation. That is an asynchronous transformation. Now, looking at this figure, which transformation do you think would be an asynchronous transformation? So if we look at our design, we are doing an aggregation. The first transformation that we have used is an aggregation. So aggregation, what we are doing here is counting the number of employees, grouping by the job title. So can this be done record by record? It can be done. It cannot be done record by record, that is for sure, because you need to hold the job title and all the related employees in the memory, that data in the memory, then you need to perform a count on that. So you need to hold the data in the memory for each job title. So it's not that you just read the first record, perform some calculation, output that record. So that cannot happen. So this is some kind of synchronous. You do not need to hold all the job titles all at once, but you need to hold some records at least. So you need to hold all the records, all the employee records for each job title that you have in memory. So you need to hold some records in the memory. So we'll see whether it's synchronous or asynchronous. What is conditional split? Conditional split was simply when the employee count was greater than 4. So can this be executed record by record? This can be executed record by record, right? You have 10 records coming in, so it would check for each record. The first record, is the employee count greater than 4? Yes, no. Output that record. For the second record, read the second record. Is the employee count greater than 4? Yes, no. Output that record, and so on. So it can read one record, perform its operation, and output that record. It does not need to hold anything in memory. So that's a totally synchronous transformation. So that is reading one record, performing operations or transformations record by record. That is a synchronous transformation. It's efficient. It's very efficient because you do not need to hold a lot of data in your memory, so that would not slow down your process. So these operations are always faster. Now let's go to the third operation that we have performed over here, which is the sort operation or the sort transformation. How would the sorting be done? Now we have sorted by the job title. So to sort by the job title, for this transformation to happen, all the data for all the job titles needs to be in the memory, and then only the sorting would happen. So for the sort operation, all the data actually needs to be in the memory, read in the memory. Only then the sorting can be calculated, and only then all the data will be outputted. So it cannot happen record by record or row by row. So this is a totally asynchronous operation or transformation. Now these are obviously a lot slower because a lot of data needs to be in the memory. So the memory is held up for some time, and that slows down the process and the performance. So these are a little weak in the performance. These will pull down the performance of your job. Now going back to the aggregate transformation. So that becomes a partially synchronous transformation because you do not need to hold all the data in the memory, but you need to hold parts of data in the memory. So that is a partially synchronous transformation. So what do we have here? We have sort as a totally asynchronous transformation. We have the conditional split as a totally synchronous transformation, and aggregate as a partially synchronous transformation. Now, as we said, totally asynchronous transformations are pull down the performance of your ETL workflow, and that's why you should be targeting to avoid them if you can while designing your ETL workflow. So for example, if you want to do the sorting, you're reading from a database table and you want to sort the data while reading from the table, then it's always advisable to do the sorting by using an order by clause in your SQL command for reading the data, because these operations are always faster at a database level. Similarly, for aggregate operations, if they can be done at your SQL level, do them at your SQL level. So aggregate levels can get very complicated, and not all of them can be done at the SQL level. So it is an optimum choice that you have to make. Which operation can be easily done at the SQL level, which operation should be efficiently done at your ETL design level. So you have to make an optimum wise decision for using the aggregations at which level. The conditional split should always be done at your ETL design level. It's a very synchronous operation, and it performs row by row, so it's very fast. So that is how you have to design your ETL workflow, keeping all these things in mind. So asynchronous and synchronous transformations, or you can say active and passive transformations, they are called in some of the ETL languages. So this is what they mean, and this is how you design an efficient ETL workflow. So all these small things you have to keep in mind while you want to design your ETL workflow. Okay. So any questions on this so far? Okay, so I'm assuming no. If you have any questions, just type them in and I'll be happy to answer them. Okay, so now that we have 15 minutes left, I would, I can cover one more task if you wish, or if it has been a lot of tasks for you, then we can stop and we can proceed in our next session. So let me know by typing what you want. Do you want to cover one more transformation, or it's not a transformation, one more task? Okay, great. So yeah, so there have been a lot of stages, a lot of tasks that we have covered. The all basic tasks, we have seen basic transformations using these tasks, but they would help you get familiarized with the SSIS tool, and you have now sufficient options to play around with the tool and design your own ETL workflows. As I said, do go and try to install the AdventureWorks and AdventureWorks data warehouse databases, because then you'll get lots of data that you can play around with, and lots of tables would already be created. So you would have lots of stuff that you can work upon, and you would not need to create your own data every time you perform your ETL workflow. So try to use all these tasks, and try to do some practice. And when we meet next time on the next weekend, then if you have any questions, you can ask me, or you can mail them meanwhile to my email ID, and I would be happy to answer them. And so we'll proceed with the next task. We'll see some more tasks in the next session. Now the next session is going to be from 6 to 8 a.m. The next weekend. So that's EDT, 6 to 8 a.m. That's only for the next weekend. And yeah, I would share the video. So I would share the video link by today, or latest by tomorrow. I would do that. Okay, so thanks a lot for joining. If you have any questions, feel free to mail them to my mail ID, and I would be happy to answer them. And have a great week ahead, and do some practice on SSIS, and we'll meet next weekend. Thank you. Thanks a lot for attending.
Thank you.
Thank you. Bye-bye.
Bye.